This video is going to have a look at the different ways that we can get metals out of the ground. So you should now know what an ore is. If not, go back to the previous section and have a look at that. Once you know that, you should know that there are two different ways that rocks are found in the ground: uncombined and in ores. If they're uncombined, what do you have to do? Nothing. They're already there, so all you have to do is dig them out. These are for your really unreactive metals, the ones that don't react with anything in the ground to form an ore. So that's the three main examples are silver, gold and platinum. So in the exam, if it turns around and says, how do you get gold out of the ground? You dig it out because it's unreactive and it doesn't form an ore. Now, depending on the reactivity of the different elements, the different metals in the ground, there are two different ways to get those metals out of the ground. One of them is to heat with carbon, and the other is to use electrolysis, which you should be familiar with from an earlier topic. So when you heat with carbon, these are for the unreactive metals that are still reactive enough to react with things in the ground. So your copper, your zinc, iron, tin and lead. So these slightly reactive metals, which are all found in the transition metals, that middle block in the periodic table, are less reactive than carbon. And because of that, if you add carbon to it with a bit of heat to get the reaction going, the oxygen will jump from the copper or from whatever metal you've got down here onto the carbon to produce carbon dioxide. So for example, copper oxide and carbon leaves you with copper on its own and carbon dioxide. This is the same for any of the others of these metals down here. So iron oxide plus carbon gives you iron plus carbon dioxide, tin oxide plus carbon gives you tin plus carbon dioxide, and so on. The final method, which you should be familiar with, is electrolysis. Now that's splitting up a compound using electricity. This is for your really reactive metals, usually found in group 1, group 2 and some in group 3 of the periodic table. So examples are your potassium, sodium, calcium, magnesium and aluminium. Now each of these metals here are more reactive than carbon. So if you put carbon into the reaction, nothing will happen. Because the potassium in this example is more reactive, the oxygen wants to stay with it. Carbon doesn't get a say and no reaction occurs. So they have to use electricity. So what they do is they take the rock, they either melt it or dissolve it depending on what type of rock it is, and then they use electrolysis. So in the case of aluminium oxide, it breaks up when it's in molten form into aluminium and oxygen. The oxygen goes to the positive, the aluminium goes to the negative, and the aluminium will coat this so it can then be scraped off. The oxygen obviously will come off as a gas, and then all you're left with is your aluminium at the bottom. What would the examiner ask? So you could get the simple question of how would you extract tin? In which case you'll just turn around and say it's one of the less reactive metals, therefore you extract it with carbon because it's less reactive than carbon. It might turn around and ask how would you extract potassium? And again that would be use electrolysis because it's more reactive than carbon. However, what they might do is they might turn around to you and say, why do you not use electrolysis to extract iron? And the answer to that is quite simple. Electrolysis is quite expensive. It's certainly a lot more expensive than just heating it with carbon. So they won't use that, they'll use the cheapest method possible. So you could answer it something like that. Electrolysis is too expensive, therefore use carbon, as iron is less reactive than carbon and it can displace it that way. They might turn around and say, why don't you use carbon with potassium? And again that will be because carbon isn't reactive enough, so it won't displace it, it won't get rid of that oxygen from it.